Good day. I will be discussing to you today the topics included in advanced mathematics for electronics engineering. First, complex numbers. Second, power series. 3, Taylor's theorem. Number 4, Laplace transform. And lastly, Ztransform. First topic for today is complex numbers. In definition, a complex number is a number that can be expressed in the form a plus bi, where a and b are real numbers and I is the imaginary unit that satisfies the equation I squared is equals to negative 1. For example, z is equal to 3 plus 5i. Here we have a complex plane. We will plot this equation there for where axis is for real numbers and y-axis for imaginary numbers. So we will plot first the real number 3, 1, 2, 3. Then for imaginary number is 5, 1, 2, 3, 4, 5. Then the intersection for real and imaginary number is allocated as z. So for this angle, we will get that by using inverse tan times b over a, wherein inverse tan is 5 over 3. Then we will get the angle phi is equal to 59.04 degrees. And for this formula, z is equal to r times the quantity of cos phi plus I sine phi. We will get first the r, which is equal to the square root of the 3 square plus 5 square, and the answer is 5.83. Then we will substitute the values. Z is equal to the r, which is 5.83, times the quantity of cosine 59.04 plus I sine 59.04. Then we will be using also the operations in complex numbers, wherein we have addition, subtraction, multiplication, and division. An addition, we will simply add this equation. So 6 plus 3i plus 2 minus 7i. We will first add the real number 6 plus 2 is equals to 8. Then 3i plus negative 7i, we will follow the rules in addition or subtraction. So we will get the answer minus 4i. So the answer for this addition uh, is 8 minus 4i. Then for the subtraction, like what we have to do in addition, 6 plus 3i minus 2 minus 7i is equal to 4 plus 10i. Then for multiplication, we have a binomial. The quantity of 4 plus 5i times the quantity 3 plus 2i. And then we will use there using FOIL method. So we will first multiply the first terms. 4 times 3 is equal to 12. 4 times 2i is equals to 8i. 5i times 3 is equals to 15i. Plus 5i times 2i is equals to 10i squared. Wherein I squared there is equals to negative 1. Then the answer there, 10 times negative 1, it will be negative 10. Then we will be adding or subtract based on the equation. 12 plus 23i minus 10, then we will be having the answer 2 plus 23i. When for division, 3 plus 2i over 4 minus 3i times 4 plus 3i over all over 4 plus 3i. Then, so there we will be using again FOIL method for the multiplication. So we have 12 plus 9i plus 8i plus 6i square all over full method again, 16 plus 12i minus 12i minus 9i squared. For I squared is equals to negative 1, so we will substitute negative 1 for I squared. Then we will be having 12 plus 9i plus 8i minus 6. Then all over 16 plus 12i minus 12i plus 9. And following all the operations used, we will be having 6 plus 17i all over 25. So then, for the final answer, we will separate real number for the n imaginary number. 6 over 25 plus 17 over 25i. The second topic is about power series. Power series, according to the definition, it is an infinite series of the form. It is a generalization of a power series for more than one variable. For this section, we will recall the geometric series, wherein g of x is equal to the summation ax raised to n, which is equal to a over 1 minus x. Example, g of x is equal to 1 over 1 plus x cubed. Then following this formula, a over 1 minus x, we have g of x which is equal to 1 over 1 minus negative x cubed. So for the final answer, g of x is equal to the summation negative x cubed raised to n. Truncation error is an error committed when an infinite series is evaluated using finite number of terms. This time, we have series solutions. Example, solve for y double prime plus y is equal to 0. The solution for that is we will be using a geometric series formula, wherein y of x is equal to the summation base n is equal to 0, a sub n times x raised to n. Then y prime of x is equal to summation n is equal to 1, n times a sub n times x raised to n minus 1. And for the y double prime of x, which is equal to the summation base n is equal to 2, n times n minus 1 times a sub n times x raised to n minus 2. Then after that, we will plug those values according to this given equation. Then after plugging, we will shift the first power series. Then add up the two series. We will regroup the two series. Then solve for the a sub n with largest subscript. For that, we can formulate or we can make this equation. A sub n plus 2 equals to negative a sub n over n plus 2 times n plus 1. Then after that, we will plug some values of n according to this equation or formula. So we have n is equals to 0. A sub 0 plus 2 is equals to a sub 2 equals to negative a sub 0 over n plus 2, or 0 plus 2 is equals to 2. Then 0 plus 1 is equal to 1. Then so on and so forth. Then we can make an inspection. Then we can formulate this equation or formula. A sub 2k is equal to the negative 1 raised to k over 2k factorial. K is equals to 1, 2, and so on and so forth. Then a sub 2k plus 1 is equal to negative 1 raised to k a sub 1 over 2k plus 1 factorial. We have formulas for a sub n. Then y of x is equal to summation n is equals to 0, a sub n x raised to n. So this is the formula. A sub o plus a sub 1 x plus a sub 2 x squared plus a sub 3 x cubed, and so on and so forth. So we will plug these values for this formula. Then next, collect all the terms with the same coefficient, like what I have did there. Then we can formulate this answer a sub 0 summation k is equal to 0, negative 1 raised to k x raised to k to 2k over 2k factorial plus a sub 1 summation base k is equal to 0, negative 1 raised to k x raised to k 2k plus 1 over 2k plus 1 factorial. For this portion of the equation, we can conclude that this is cosine x. Then for this portion, this is sine of x. This time, we will discuss Taylor's theorem. In calculus, Taylor's theorem, approximation of a k times differentiable function around a given point by a kth order Taylor polynomial. In Taylor series, if f of x is an infinitely differentiable function, then the Taylor series of f of x about x is equal to x sub 0 is f of x is equal to summation base n is equal to 0 f raised to n times x sub 0 over n factorial times the quantity of x minus x sub 0 raised to n. Example, determine the Taylor series for the function of x which is equal to e raised to x about x is equal to 0. This is one of the easiest function. We will recall f raised to n of x is equal to e raised to x, which where n is equal to 0, 1, 2, and so on and so forth. We get f raised to n of 0 is equal to 1, which n is equal to 0, 1, 2, so on and so forth. Then, we have e raised to x equals to summation base n is equal to 0, x raised to n over n factorial. Another example, f of x is equal to e raised to x about x is equal to negative 4. This is virtually identical to the previous example. We notice that f raised to n of negative 4 is equal to e raised to negative 4, n is equal to 0, 1, 2, so on and so forth. Then, our final answer for that is e raised to x equals to summation of n is equal to 0, e raised to negative 4 over n factorial times x plus 4 raised to n. This time, I will discuss to you the transforms used in advanced mathematics. One of those is Laplace transform. The Laplace transform is an integral transform and is useful in solving linear ordinary differential equations. And in definition of a Laplace notation, this is the formula. This is the Laplace operator, f of t equals to the integral of e raised to negative st times f of t dt. This part, e raised to negative st, is what we call kernel of transformation. Then, the variable s here is complex variable. Example, f of t is equal to 6e raised to negative 5t plus e raised to 3t plus 5t cubed minus 9. In solving Laplace transform, we should know very well the table of the Laplace, so we can solve this given equation. So, in solving that, the f here, the small f will become capital F. Then the time here, or the t, will become s domain. Then this equation is equal to 6, according to the table of Laplace, 1 over s minus negative 5 plus 1 over s minus 3 plus 5 times 3 factorial over s raised to 3 plus 1 minus 9 times 1 over s. Then, we will simplify the equation. 6 over s plus 5 plus 1 over s minus 3 plus 30 over s raised to 4 minus 9 over s. Example number 2. We have given g of t equals to e raised to 3t plus cosine 6t minus e raised to 3t cosine 6t. So, the g again will become capital G, then the t will become s. And following the table of Laplace, this equation will become 1 over s minus 3 plus s over s squared plus 6 squared minus s minus 3 over s minus 3 squared plus 6 squared equals to, simplification of this, 1 over s minus 3 plus s over s squared plus 36 minus s minus 3 over s minus 3 squared plus 36. This time is about inverse Laplace. We have given 7s minus 6 over s squared minus s minus 6. This is in Laplace form. So we will invert this. So 7s minus 6 over, we will separate this by this, s minus 3 times s plus 2 in binomial form. Then, we will be using a partial fraction equation. So, a over s minus 3 plus b over s plus 2. To find a and b, we will use their cover-up method. So, in finding a, I will cover this and this. So, we have 7s minus 6 over s plus 2, which is equal to 7 times 3 minus 6 over 3 plus 2. This is equal to 3. For b, 7s minus 6 over s minus 3 equals to 7 times negative 2 minus 6 over negative 2 minus 3, which is equal to 4. So, we will substitute the values of a and b. 3 over s minus 3 plus 4 over s plus 2. And following the table of Laplace, we will have 3e to the raised to 3t u of t plus 4e raised to negative 2t u of t. Then, simplify 3e raised to 3t plus 4e raised to negative 2t u of t. Another transform we will be using here in this course is Ztransform. In mathematics and signal processing, the Ztransform converts a discrete time signal, which is a sequence of real or complex numbers, into a complex frequency domain representation. Ztransform is a discrete time equivalent of Laplace, and sampling is equal to the transformation of continuous time to discrete time. Continuous time is denoted by a parenthesis, and discrete time is bracket. Example, find x of z. X of n is equal to 1/3 raised to n u of n plus 3 to the n u times negative n minus 1. So, we will transform first this portion. 1/3 to the n u of n will become 1 over 1 minus 1/3 z to the negative 1, wherein z is greater than 1/3. Then, this portion, 3 raised to n u times negative n minus 1 will become negative 1 over 1 minus 3z to the negative 1, wherein z is less than 3. Next, xz is equal to, we will follow this sequence. 1 over 1 minus 1 third z to the negative 1 minus 1 over 1 minus 3z to the negative 1. Then we will simplify this equation by like this, what I am do. Then it will become x of z equals to negative 2 raised to 2 thirds z to the negative 1 over 1 minus 1 third z to the negative 1 times 1 minus 3z negative 1. Then the final answer for this equation is negative 2 cubed, or 2 over 3 z to the negative 1 over 1 minus 3 times 1 third z to the negative 1 plus c to the negative 2. For this part, we have inverse z. Example, x of z is equals to negative 1 plus c to the negative 1 plus 0.2 z raised to negative 2 plus 0.9 z raised to negative 3 plus 1.2 z raised to negative 4. We will invert this z form into this. So it is equal to negative delta delta of n plus delta n minus 1 plus 0.2 delta n minus 2 plus 0.9 delta n minus 3 plus 1.2 delta n minus 4. Simply as that. That's all. Thank you for watching. Goodbye.